Leetcode 1996, the number of weak characters in the game. So you are playing a game that contains multiple characters, and each of the characters has two main properties, attack and defense. You are given a 2D integer array properties where properties of I is equal to attack I, defense I, represents the properties of the ith character in the game. A character is said to be weak if any other character has both attack and defense levels strictly greater than this character attack and defense level. More formally, a character I is said to be weak if there exists another character j where attack j greater than attack I and defense j greater than defense I. So return the number of weak characters. So we are given some properties of some characters in a game, and this properties represents two values, attack or defense. So properties of I denotes attack of that particular character and also the defense of that particular character, and it is a 2D integer array. Now we need to find whether a character is weak. We need to count the number of weak characters. So a character is said to be weak if the attack level and the defense level is less than another character's both attack and defense level. So suppose we are having a character A here, and we are having another character B, and this is having an attacking level say 100, and B is having a defensive and A is also having a defensive property of say 150, just two values. Now B is having attacking level of just 10, and this is for attacking. So B is having an attacking level of just 10, and it is having a defensive level of just 100, say 100. So when we look at this, the attacking level of A is 100, and this is greater than the attacking level of B. Now as well as just looking just the attacking level, we also just check the defense level. So defense level of A is 150 and 150, and attacking level defensive level of B is 100, and 150 is also greater than 100. So both the attacking level and defensive level of character A is greater than the attacking level and defensive level of character B. So B is said to be weak. So B will be weak. So now so this is what actually we need to find. We need to how many number of weak characters will be there. So if there is some other character, say C with an attacking of say just 5 and defensive of just 9, and this is also another weak character. B is a weak character because it is having lesser attacking and defensive power than A, and C is also a weak character, and it is also having a lesser attacking and defense than A and B. So this is another weak. So if we are given something like this as an input, then the answer will be 2. Now let's get into the input. Here 556336. So let's take that. So 556336. So let's have 3 players A, and we have another player B, and we have another player C, and A is having an attacking level of 5 and A is having a defensive level of 5. Now B is having an attacking level of 6 and B is having a defensive level of 3. Now C is having an attacking level of 3 and C is having a defensive level of 6. Now let's compare A and B. A's attacking power is 5. B's attacking power is 6. So attacking power of B is greater than 5. But when we check with the defensive power of A is greater than 5. So we cannot say this, that is A is a weak one with respect to B. We can also just check with C. So we check whether A's attacking power is greater than C. So if we check that, 5 is greater than 3. With respect to 3, that's C. Character C, its attacking power is just 3, it's having 5. But when we check with the defensive power, this is having 6, this is only having 5. So C is greater. So with respect to A and C, while comparing A and C, we cannot just find a character which is weak. Now we can also just check with B and C. Here B is having greater attacking power, but B is having lesser defensive power than C. So from this example, we will not find any weak character. Either one is good in attacking, otherwise the other one will be good in defending. So here the answer will come out to be 0. And the brute force approach is just checking each and every characters with one another along with its attacking and defensive. So the complexity will be big of n square. So where n is the total number of characters. So we need to compare with every combinations of the characters. Now let's check with the other example. Let's take this example 1 5. So let's check this example. So here also we are having 3 characters. Here we have a character, we have a B character, we have another character C, and A is having an attacking power of 1, defensive power of 5. B is having an attacking power of 10 and defensive power of 4. C is having an attacking power of 4 and defensive power of 3. So when we compare A and B, A is having lesser attacking power, but A is having greater defensive power. So we cannot get into a conclusion like which one is a weak. We cannot find one. Now we can compare A and C. When we compare A and C, C is having greater attacking power, but A is having greater defensive power. So with respect to A and C, again we cannot find any weak character. Now let's compare B and C. Now when we compare B and C, we can see the attacking power of B is 10. It is greater than this 4. So B is having greater attacking power. Now as well as when we check with the defensive power, 4 is greater than 3. So here when we take these two examples, both the attacking power of A and defensive power of B is greater than C. So C is weak. C is weak. So here this is a weak character that we are looking for. So here we will return 1. So when we compare every combinations, we need to do big of n square times. Now is there any better approach? For most of the problems, when we see like this ranges in a 2D array, we can just think of sorting based on the attacking array or the sorting based on the defensive one. When we sort, here what we need to do means, here we can sort the character based on attacking power in decreasing order. So when we sort the characters based on the decreasing order, we will get 10, 4, then we will get 4, 3, then we will get 1 comma 5. Now we already checked the attacking power because we sorted it already. So the second character's attacking power will surely be less than the previous ones. Same way, the third character's attacking power will be less than the previous ones. Now we just need to check for this one, just the defensive power. So we can just look for 4 and 3. We find that 4 is greater than 3, and we already know that 10 is greater than 4. The attacking power is greater. Now we just need to care about the defensive power. So 4 is greater than 3, so we can increment the count just by 1. Now what if this were also 10? So when this was also 10, here we sorted based on the decreasing order, like decreasing order of the attacking power. But here we have two equal attacking powers. When we have equal attacking power condition, we need to sort based on increasing order of defensive power. So when we do that, we get 10 comma 3 first, then 10 comma 4, then 1 comma 5. We get 1 comma 5. So in this case, there will not be any weak character. Here the answer will be 0. So this is the condition that we need to do. That is, when we need to sort the given 2D array based on the decreasing order of the attacking power, and when in some conditions the attacking power will be same, and at that condition we need to sort based on the increasing order of the defensive power. Now after doing that, we can just compare the defensive power and calculate the count. So this is what we actually need to do. So let's try to implement. So if our already given properties is equal to null, or properties dot length is 0, just pre-check. There is no properties array, we can just 0. We can just didn't consider this because it's already given the length will be from 2, but we can just again check for that, and we can just say less than or equal to 1. For 1 also there will be only just one element, so there will not be any minimum. Now we need to sort based on attacking power in descending order. When attacking power is equal, sort based on increasing order of defensive power. So that's our formula here. So let's have the length, how many candidates. So we can say how many character, into characters, it will be properties dot length. Now we need to sort, arrays dot sort of properties. Just doing this arrays dot sort of properties will not do the trick. We need to add a custom comparator, and in Java it can be easily done using the lambda function. So here from this properties 2D array, we will be getting two property. Let's say call it property 1 and property 2, and property 1 of 0 means attacking power. Property 1, let me write it here. Property 1 of 0 means attacking, and property 1 of 1 means defensive, Same way, property 2 of 0 means attacking, and property 2 of 1 means defensive. So from these properties we apply a lambda function. So we will get two property 1, property 2, when we will be comparing these two. And how? This is a small syntax error from here we need to pass. So when we are making the attacking power in descending order when the attacking powers are not equal. So when property 1 of 0 is not equal to property 2 of 0. So when they are not equal, then the ternary operator, then we will be doing the decreasing order way, property 1 of 0. Otherwise it may be equal. If it become equal, we need to sort based on the increasing order of the defensive power. So integer dot compare of property 1 of 1 comma property 2 of 1. So now the arrays will be sorted. So if this is our array, so if this is our input, after doing this sort operation, this will be rearranged as 10, 4, 4, 3 and 1, 5. Now if we have any equal elements, as I explained earlier, like if we have another 10 here, then we are making it will be arranged based on the increasing order of the defensive power. So it will be 1, 3 first, 10, 3 first, then 10, 4, then 1, 5. So like this. Now so now we sorted. So now we sorted based on the attacking power. So the attacking power of the first character will be larger than the second, and it will be larger than the third, like that. So now we just need to care about the defensive power. So let's say int minimum defensive power equal to a small value. Let it be integer dot min value. Now let's take the weak count, which is equal to 0. Now we just goes through each and every character inside the properties array, and we just check if the minimum defensive power is number of weak characters. If the minimum defensive power is greater than property of 1, so at that time we just increment the weak count, and we will be updating the minimum defensive power with the maximum value. Now we can just return the weak count at last, and this will be the answer. Okay, here it's a typo. I need to put the colon here instead of the question mark, because that's the ternary part. This is the true condition. So in ternary we will put the condition, and after the question mark it will be true, and after the call it will be the else part. So let's test with all the test cases. So the sample test cases are passed. Let's submit it. Okay, so here the time complexity, here we are doing sorting, so big of n log n, and here we are going through each and every character, so here it will be big of n, so big of n log n plus big of n, big of n log n plus n, so it's big of n log n. And in case of space complexity, it's since here we use the quicksort, this arrays.sort internally uses quicksort, and quicksort uses a space complexity big of log n, so space complexity will be big of log n.